Hey everyone! Today we're going to learn how to solve an equation with variables on both sides. Those are problems that look kind of like this. In this problem, we have 4x plus 3 equal to x plus 12. Notice we have an expression equaling to another expression. So when you're solving a problem like this, what you're really doing is to find what x has to be so that when you evaluate both of them, they are equal in value. Here's what I mean. What if x is 0? So now if I plug in 0 to both expressions, do they equal in value? Well, let's try it. 4 times 0 plus 3. Well, that just gives us 3. For the second expression, 0 plus 12. Well, that just gives us 12. But is 3 equal to 12? No. So for that example, x equals 0 is not a solution to this equation. Let's try a different number like x equals 1. Now if I plug in x equals 1, let's see what happens. Let's see if they're equal in value. So if we plug in 1 to the first expression, we get 4 times 1 plus 3. That just gives us 7. For the second expression, we have 1 plus 12, which is 13. But again, is 7 equal to 13? No. So x equals 1 is not a solution to this equation. Let's try x equals 2 this time. Now if I plug in x equals 2 to both expressions, let's see what we get. We get 4 times 2 plus 3, and that just gives us 11. But on the right side, we have 2 plus 12, which gives us 14. But again, is 11 equal to 14? No. So x equals 2 is not a solution to this equation. Now let's try one last time, but this time let's try x equals 3. Now let's plug in x equals 3 and see if they're both equal in value. If we plug in x equals 3 to the first expression, we have 4 times 3 plus 3. Well, 4 times 3 is 12, plus 3, that gives us 15. On the second expression, we have 3 plus 12, which also gives us 15. So 15 on the first expression is the same value as the 15 on the second expression at x equals 3. Therefore, x equals 3 is the solution to this equation. Okay, so that took us quite a long time to figure out that x equals 3 was a solution. In fact, sometimes solutions can have negative numbers, they can even be fractions or decimals, and the equations that you might be solving can even be more complicated or complex. So in algebra, we developed a strategy to help us solve equations that look like this. The process or the strategy is called isolating a variable. Now, isolating a variable means to get x, the variable, by itself. This is because we want our solution to say 1x equal to a number like 3. Notice we don't want to say something like x plus 5 equal to 3 or 2x equal to 3. We just want 1x equal to 3. We just want 1x by itself, equaling to a number or solution. Okay, so now I think we're ready to solve that exact same problem by isolating the variable x. In this problem, we have 4x plus 3 equal to x plus 12. Now, x is on both sides. We have 4x on this side and we have x on the other side. So to isolate the variable, I have to get rid of either this x or this 4x. It actually doesn't matter which one you want to get rid of, as long as x is all in one side. For this example, let's just get rid of that positive 1x. To get rid of that positive 1x, I'm going to put a minus x. That's the opposite of a positive 1x. Positive 1x combined with a negative x or a minus an x goes away. But I can't just subtract x on just one side. That doesn't keep the equation balanced. To keep the equation balanced, if I take away 1x on one side, I have to do the exact same thing to the other side of the equation. Now 4x minus 1x just gives us 3x. And I'm just going to copy everything else that I have. Don't forget the equal sign. And there you go. Notice now I only have x on one side of the equation. I have 3x plus 3 equal to 12. Now, since x is on the left side of this equation, I have to make sure that all the constant terms, the 3, is now on the other side of the equation. X is here, so I need to remove this positive 3. What's the opposite of a positive 3 or adding 3? The opposite of adding 3 is subtracting 3. But again, I have to respect the equal sign, the equality. So if I take away 3 on the one side of the equation, I also have to take away 3 on the other side of the equality. So what do I have? I have 3x. Don't forget the equal sign. It has to equal 12 minus 3. 12 minus 3 is just 9. Now notice I have all the x terms on the left side and all the constant terms on the right side of the equation. So we're almost done, but x is still not by itself. To isolate the variable x, it says 3 times x. Well, how do you get rid of something that says times 3? What's the inverse operation, the opposite of timesing something by 3? The opposite of timesing by 3 is dividing by 3. That's because 3 divided by 3 just becomes 1x. But again, I can't just divide 3 on the one side of the equation. I have to respect the equality by doing the same thing, dividing by 3 on the other side of the equation. So what is 9 divided by 3? 9 divided by 3 is now 3. So we have now 1x equal to 3. And that is a solution to this equation. Now let's try another problem that looks kind of like this. Okay, so we have another problem we can solve. We got 13 minus 4x equal to 1 minus x. Now to isolate the variable x, I have to either get rid of the minus 4x or the minus 1x. It doesn't matter which one you want to get rid of, as long as you do get rid of one of them. For this one, let's go ahead and get rid of this minus 4x. So what's the inverse operation of minus 4x or the negative 4x? To do the opposite, that's going to add 4x. But again, if I add 4x to one side of the equal sign, I gotta respect the equality by adding 4x to the other side of the equal sign. So this negative 4x and the positive 4x goes away. So what do we have left on the left side? We have 13, don't forget the equal sign, then we got that positive 1, and then we have this negative 1x or the minus x combining with this positive 4x. So what happens when you combine them? Well, I have positive 4 and I have negative 1. Since I have more positives, when they combine, I have positive 3x left. Okay, now notice I have x terms on the right side of the equal sign right here. So since all the x terms on the right side of the equal sign, I have to get rid of all the other constant terms on that side, so that all the constant terms are only on the left side of the equal sign. So since 3x is right here, the constant term is 1, so to get rid of the positive 1, the inverse operation is to minus 1 on that side. But to respect the equality, if I want to take away 1, I have to also take away 1 on the other side of the equal sign. So what is 13 minus 1 on the left side? We have 12. Don't forget the equal sign. And then what's on the right side? We have 3x. Okay, now we're almost done isolating the variable x, but again, we have 3x or 3 times x. Okay, so how do you get rid of something that says 3 times x? What's the opposite or the inverse operation of timesing something by 3? To get rid of something that says times by 3, the inverse operation is to divide by 3 on both sides of the equal sign. So what is 3 divided by 3 right here? Well, 3 goes into 3 one time. That's why you only have 1x left over. See how we isolate the variable right here? We have 1x left. Here, 12 divided by 3 is actually 4. So the final solution is 4 equal to x, which is the same thing as saying x equal to 4. Okay, so how would I know if x equals 4 is the actual answer to this equation? We can do the exact same thing we've done before by plugging in x equals 4 to both expressions to see if their values are equal. Let's go ahead and try that. So we got 13 minus 4x. But instead of x, we're going to evaluate at 4. Let's see if that equals the other expression, 1 minus x. 1 minus, but instead of x, we're going to evaluate at 4. Okay, so I have 13, and then negative 4 or minus 4 times 4 is a minus 16. 1 minus 4, that's just 1 minus 4. Okay, so 13 minus 16, and remember, minus and a negative do the exact same thing. So if I have positive 13 combined with negative or minus 16, positives, negatives cancel. So do I have more positives or do I have more negatives when they cancel? In this example, since I have 16 negatives and only 13 positives, I have more negatives. But how many more negatives do I have? I have 3 negatives left. Let's take a look at the other side. I have positive 1 and then I have minus 4. And again, minus 4 is the exact same thing as a negative 4. So if I have negative 4 or minus 4 combined with positive 1, do I have more negatives or do I have more positives when they combine? Well, when they combine and cancel, I definitely have more negatives left. How many more negatives do I have? I have 3 negatives. And take a look at x equals 4. When I plug in x equals 4 into both expressions, we get the exact same values. Therefore, x equals 4 is the solution to this equation. Now let's go ahead and try another problem. Okay, so here's another problem that we can solve. We got negative 3x minus 32 equal to negative 10 plus 8x. Now to isolate the variable x or to get x by itself, I have to get rid of either this one or that one. It doesn't matter which one you get rid of, as long as you get rid of one of them. So do I want to get rid of negative 3x here or the positive 8x here? Let's get rid of the positive 8x. Okay, so how do I get rid of the positive 8x? What's the opposite or the inverse operation of adding or positive 8x? Well, adding 8x, the opposite is minusing or subtracting 8x. But to respect the equality, if I subtract 8x on the one side of the equal sign, I have to do the exact same thing to the other side of the equal sign. Notice that I moved the negative 8x on this side, not here with the negative 32, because these two are alike terms. These two combine. So on the right side of the equal sign, I have a negative 10. And that's it, because this positive 8x and the negative 8x, they go away. Now what's on the left side? Well, I have negative 3x and a negative 8x, or the minus 8x. So when they combine, what happens? Well, remember, positives and negatives cancel, but notice they're both negatives. So nothing cancels out. In fact, they just combine. When they combine, you have negative 11x. What else is left on the left side of the equal sign? I still have that minus 32. Okay. Now we have x on the left side of the equal sign. To get x by itself, I have to make sure all the constant terms, or the negative 32, and remove that so that everything on the left side is the x terms and on the right side are the constant terms. So since x is here, I have to get rid of the negative 32. So what's the opposite of a minus 32? The opposite or the inverse operation of a minus 32 is to add 32. Now I can't just add 32 to the left side. I have to respect the equal sign by adding 32 to the other side of the equal sign. Negative 32 and a positive 2 goes away. That just becomes 0. So we have a negative 11x equals to negative 10 plus 32. Now here, negatives and positives cancel. It's not like this example right here where they're both negatives. When they're both negatives, they just combine. But here I have a negative 10 combined with positive 2. So do I have more positives or do I have more negatives? In this example, I definitely have more positives. But how many more positives do I have left? I have positive 22 left. Okay, so now we have negative 11 times x equals to 22. So to get x by itself, I have to get rid of this times negative 11. So what's the opposite or the inverse operation of times negative 11? Well, the inverse operation of timesing negative 11 is to divide by negative 11. Now negative 11 divided by another negative 11, they go away to be a positive 1x. Remember, when you divide two negatives, it becomes a positive 1x here. But what happens when you do 22 divided by a negative 11? Since there's only one negative, 22 divided by 11 is not just 2, but a negative 2, because it's not double negatives here. We're only dividing by one negative, so it's a negative 2. So the solution for this equation is x equals negative 2. So what can we do to figure out if our solution is correct? We can do the exact same thing by plugging in to both of these expressions to see if x is negative 2.